The road, the car, the driver. With more than 60 million cars operating now and more millions being added every year, the road, the car, and the driver must be considered a system. All three must be in harmony. Research and development under this concept ensures increased highway efficiency, driving ease, and safety for the future. This film is the story of some of General Motors Research Laboratory's forward-looking projects. Many will never be used in their present form, but they do provide a basis for practical advances in the future, each a carefully conceived approach to better driving. One of the projects is HiCom, Highway Communications, a versatile new driver aid designed to transmit voice messages from low-frequency roadside transmitters to passing vehicles. HiCom operates whether the car radio is on or off and can be heard only by the passing car. Voice messages can originate from magnetic tape or from a master control station over existing telephone lines. Here is a demonstration system built by ACDelco Radio Division. Rugged and dependable, transmitters may be permanently installed above or below ground.
Warning, bridge out, detour ahead. Ice ahead, slow to 30.
The receiver in the car may be combined with the standard radio, or it may be a temporary separate unit, rented perhaps for driving on a highway equipped with HiCom. This separate unit, being next to the driver's ear, is audible even without momentarily blanking out the car radio. By providing necessary information to the driver through his ears instead of his overworked eyes, safety and operating ease are increased. Highway efficiency could be increased by rerouting traffic when major traffic jams occur.
State Highway Copter to Thruway Master Control. Dangerous oil slick on road from overturned tanker.
Divert westbound traffic to Route 27.
Attention all westbound vehicles.
A tape is immediately recorded and the message goes out over the permanent transmitters in the affected vicinity.
Attention all westbound vehicles. Turn right on Route 27.
If a permanent transmitter is not located in the area, a patrol car with a portable transmitter can be dispatched. Direct broadcast is possible when necessary. In many instances, permanent transmitters are not serviced by a master control station. Here, stock pre-recorded messages may be used. That's HiCom, one step toward easier, safer driving. And for more comfortable driving, test cars roll over the flat, burning desert highways of the Southwest. The tortuous, twisting roads of the Rocky Mountains, the bumpy, rutty lanes of the backwoods, just to memorize roads. That's right, memorizing roads on magnetic tape. Later, in the research laboratories, the tapes are played back through complex electronic calculators to equipment that makes a test car body behave as though it were actually on the road. Also, for any road, engineers can electronically introduce different suspensions, springs, and car size and weight. So, in effect, they can change the car to many different cars, helping designers bring about further comfort and safety. As a final check, they put people in the test car, get their reaction, for people ride in the cars that travel the roads. People, not computers. On the test track, This variable stability car, built jointly by GM Research Laboratories and Cornell Aeronautical Laboratories, is used to measure driver reaction to various systems. Driving characteristics can be electronically changed to make the car handle in many different ways. Steering gear ratios can be varied, steering wheel tensions can be changed. Here, steering is adjusted to a 5-to-1 ratio. To study extreme conditions and their effect on the driver, the ratio can be upped to 40-to-1. As a matter of fact, this car can be guided without even turning the steering wheel, merely by pressure alone. The important thing is that studies like these show designers how to tailor steering qualities for maximum safety. Another experimental project by Delco Radio Division, designed to increase driver safety, is the use of radar to detect obstacles in fog or darkness. And here's another concept. No accelerator, no brake pedal, no steering wheel. All controls centralized in one small stick. That's Unicontrol, created by GM Research Laboratories. A whole new approach to driving. Behind this one small stick, years of experimental work and development, and a great deal more to come, searching for bits and pieces of information and gradually piecing them into a practical application that looks to the future. Unicontrol. Of course, every new development suggests a refinement or another approach to the problem. Saginaw Steering Gear Division is experimenting with a rotating knob for steering control. There will be other approaches too, but one thing is certain: in the future, driving and parking will be easier and safer. Steering may even become automatic. In this GM Research Laboratories car, the driver still operates accelerator and brakes. But look, no hands. This leaves the driver more relaxed to enjoy the trip and free to devote more attention to other driving responsibilities. The first electronic guide cable for this test system was laid in 1957. The system, called AutoGuide, is the result of GM know-how and continuing close cooperation with highway experts. Two antennas on the car pick up low-frequency radio signals from the buried cable and transmit steering directions to the car. Watch now as this car, traveling out of its lane and under manual control, is switched to AutoGuide. Think of what this could mean for the future. Fully automatic highways. No need for driver to touch steering wheel or accelerator or brakes. A full-time electronic chauffeur service for expressways and limited access roads. In this scale model, built in cooperation with AR&T Electronics Company, the buses normally travel at a speed equivalent to 60 miles an hour. The speed of the leading vehicle automatically determines the speed of vehicles behind it. When an obstruction appears, traffic is automatically slowed to half speed and then brought to a stop. When the obstruction is removed, traffic resumes. In addition to driver safety and comfort, an automatic system could increase the capacity of highways and help to cut highway costs. By eliminating driver reaction time, traffic could flow faster. Since traffic specialists traced most accidents to driver error, it is obvious that a reliable automatic system could greatly reduce accidents. In the automatic control system, the guidance cable buried in the pavement is made of crisscrossed wires. 2 pickup coils mounted on the underside of the car follow this electronic path. The wires cross at equal intervals, and another pickup coil on the car measures the car's speed by counting these crosses. Another wire embedded in the road tells the car how fast it should be going and controls accelerator and brakes. A block system of wire loops detects obstacles and sends signals back down the road to automatically slow or stop traffic. When manually operated vehicles travel on the automatic highway, they must obey a block system of lights showing traffic conditions ahead. The electronic components in this model bus are the same size as the components necessary to pick up control signals in a full-sized vehicle. Auto control is in the early development stages, but it represents one workable approach to a very complex problem. Built mainly for research, it has also stimulated great interest in the automatic highway concept. Here in Washington, D.C., some of the nation's leading traffic engineers, highway safety experts, and government officials welcome the opportunity to inspect this potential solution to problems of highway safety and efficiency. Firebird 3, an experimental car, a space-age car, yet the easiest to drive car ever built. Here are practical working systems for the future, all in one car. Unicontrol, steering, accelerator, and brakes in one control. Auto Guide, automatic steering for the future. Automatic highways also to take over speed control and detection of obstacles. And riding with it, painstaking research, new and cautious approaches, advanced test equipment. A functional report to you from General Motors scientists, engineers, and designers.
Easy street exit, right 500 yards.
None of these systems has been developed overnight. Some may never be used in their present form. But from such research and development come ideas to spark practical advances for the future. So pure fundamental investigation directed at the road, the car, and you as one inseparable unit will one day have you traveling on Easy Street.